Hello everyone, I am Christopher from Arduino, and today I'm going to show you how to leverage Modbus TCP industrial communication protocol using the Arduino products family. The Modbus protocol is a messaging service structure using a client-server communication. It is an application protocol widely adapted for industrial communication over Ethernet networks. It allows industrial devices to exchange data and control commands efficiently and reliably, making it an essential component in many industrial automation systems. In today's video, we are going to use a Portenta Machine Control and an Opta Micro PLC to go through a step-by-step process on how to communicate them using Modbus TCP. The shared data will be the temperature from a Type K thermocouple. An Ethernet cable will be used for the communication. Both devices will be powered by 24 volts using these power supplies and will be initially configured using USB cables, a micro USB for the Portenta Machine Control and a Type-C for the Opta. On the software side, we need the PLC IDE that can be downloaded for free from the Arduino official website. In the Portenta Machine Control, connect the thermocouple terminals to TP0 and TN0 respectively, the 24 volts power supply to the 24 volts input and ground. In the Opta Micro PLC, we just need to connect the power supply to the respective inputs on the screw terminals. Now that we have everything ready for this integration, let's open the PLC IDE and create a new project for the Portenta Machine Control that will be the server or slave. We need a license for this product to be used with the PLC IDE that we can buy directly from our store. It will include a product key that we need to activate the device. We first connect the PMC to our computer using a micro USB cable. Our runtime needs to be manually flashed so we can be programmed using the PLC IDE. For this, select the device serial port and click on Download. It will take some time to compile and download the sketch. Once done, navigate in the upper menu to Online tab, Set up Communication, and select the higher serial port on the Modbus protocol properties. Now we can click on the Connect button, and we should see the connected tag on green in the right corner. As we can see, the device status says no license. To activate it, we just need to paste the product key that we just bought and click on the Activate button. We must reset the PMC for the change to take effect. Connect it again and click on the Refresh button. Now the status says OK. This means that we successfully activated the Portenta Machine Control. For the Modbus TCP configuration, we go to the Resources tab, Ethernet, and as we notice, the Modbus TCP slave mode is always enabled, so we don't have to change anything here. Now we go to the sketch editor and uncomment the setup function configurations. As the IP, we must use the same as the Portenta Machine Control. As we have it connected to our router, we can find it on its configurations. In my case, it's 10.0.0.157. In the DNS and gateway arguments, we use the router IP and the subnet is left as it is if our network one isn't different. Let's create the variable that will be shared with the temperature sensor data in the network. For this, we go to Status Variables and click on Add. We give it a name, in this case temp_sen, change the variable address to 25,000 and the type to real. Next, we go to Temperature Probes and select the sensor type. In this case, we will be using a thermocouple connected to the first channel, which must be enabled by setting it to true. And finally, let's go to the main program and match the temperature variable with the temperature sensor lectors using this function, systemp_probes from channel 0.temperature. To check if everything is okay, click on Compile. And if no error is shown, we can upload the code to our Portenta Machine Control. Once uploaded, we can monitor the temp_sen variable in the watch window, dragging and dropping it from the global shared variables in the project tab. We should see the temperature value measured by our sensor. Now we have configured the server, let's create a new project for the Opta Micro PLC that will be the client or master. At first instance, the Opta needs to be manually flashed with a runtime so it can be programmed using the PLC IDE. For this, connect it to the PC using a Type-C USB cable and navigate to Online, Set up Communication, and make sure the Modbus protocol is activated and the Opta serial port is selected. click OK and OK again. The Opta doesn't need any license activation to be used with the PLC IDE. Double-click in the Opta index to refresh the configuration window, and now under the Opta image we can select the serial port. Once selected, click on Download, click OK to the warning, and let's wait to the runtime to be uploaded. The USB connection isn't necessary anymore. We need to connect the Opta to our local Ethernet router using an Ethernet cable for further configurations. Just as we did with the PMC, we can find the Opta IP address from the router list of connected devices. Once we have it, on the PLC IDE we go to Online, Set up Communication, and select the Modbus TCP protocol. Click on Properties and enter the IP address in the IP or hostname text box. Click OK and OK again. Now we can click on the Connect button, and if everything is OK, here we would see the connected status on green. On the Ethernet tab, enable the Modbus TCP master mode. Then right-click on it, click on Add, and select the generic Modbus device. On the general device settings, enter the server IP, the Portenta Machine Control 1, right-click on the device, and add the FC04 Modbus function that will let us read the server input registers. Now, let's click on the function, and in the general settings, enter the shared variable address that we defined earlier in the server, 25,000 in this case. In the input register tab, let's create a label for it. Could be temp_reg. As we did with the server, let's navigate to the sketch editor and set the device IP address with the Opta one, the DNS and gateway with our router address, and that's it. Finally, we are going to define the Opta output behaviors in function of the temperature read from the Portenta Machine Control. For this, we go to the Resources tab, Relay Outputs, and we give a variable name to each relay. In this case, I will call them Relay 1, 2, 3, and 4 respectively. The same with the LED outputs, LED 1, 2, 3, and 4. Now let's go to the main code in the Project tab. Here we are going to create a variable by right-clicking on the Local Variables window and then Insert. Let's call it temp local, and integer as a type. In the code editor, let's match the local variable with the shared one sent by the Portenta Machine Control. And once we have it started locally, we can design the logic to control the outputs as we want. I will set 4 different temperature levels to control each output with the temperature rise respectively. In this case, I choose 30, 50, 70, and 100 Celsius degrees that will be turning on each relayed output and its respective LED. With the final code written, let's compile the project and upload it to the Opta Micro PLC. We can leave each device connected separately to our Ethernet router or connect them together directly with one Ethernet cable. The first option will let us update the preferred device remotely, as we can access to it through the local network. Now let's turn on the heat gun and see how the relay outputs are activated, while we can also monitor the temperature in the IDE. When we reach 50 degrees, the second output will light up, and so on until we reach 100 degrees. As the temperature cools down, they will begin turning it off until the temperature returns back to normal. In this tutorial, we learn how to communicate two Arduino Pro products using the Modbus TCP protocol, demonstrating a simple application of sharing temperature data to control a device outputs. As we can notice, the configuration process is very straightforward and the results were as we expected. If you are interested in knowing more about industrial protocols and our product's capabilities, I invite you to follow the guides I left in the description. And I really hope you enjoyed this video. Subscribe for more and have a great day.